this is your solid. The definition of solid, you must remember that. Then we will come to the characteristics of solid and different types of solid which we use in our different purposes, maybe sometimes daily also, but sometimes or during celebration of worship time. So these are the next one. Akash Dilna, can you identify the picture? What is this? Vedanti, what's that?
It is ghanta bell.
Bell. Used for?
This for making the sound.
Yes, making the sound, right. So it is making the sound during worship time, right. So these are also, we can say these are also our solid. I will show you one video clip. I would like to show you a video clip, and from there I would like to get idea about the characteristics of solid also. So check this one, and then we will try to understand the characteristics. So here we are trying to see one thing, try to see this thing and understand. Now a few things we have to know, name now onwards. This is one thing, no metal, which is known as sodium, but the symbol in symbol it is mentioned as Na because its Latin name is natrium. By that way it is known as Na. It is sodium. So this metal, check this one, and we have to understand the characteristics of it.
And chlorine are examples of atoms that combine ionically. Sodium is a reactive, soft, silvery metal of low density.
So have you observed one characteristics of this element? Vedanti, can you say what characteristics we observed now?
It is the combine of silver with low density.
No, I couldn't get the last part of your answer.
It is the combine of silver, material silver, with low density.
No, it's not silver. It's an element known as sodium. Silver is a separate element. It is sodium, but we have checked one property. Once more, you see and observe.
Are examples of atoms that combine ionically. Sodium is a reactive, soft, silvery metal of low.
Vedanti, can you say what characteristics we have observed now?
It is the combine of something allen or something there.
No, what it has said in the voice, we need not to think about, but think what is done. What is done with it? Yes?
It is cut from the middle.
Okay. Akashrina, have you observed anything, and can you say the characteristics of some solid?
Sodium is a silvery soft metal.
Okay. So we will check one thing, but though it will not be our during this time discussion, but you check this thing, it will help you to understand other things also. Check this.
Density. Its atoms have one valence electron. Chlorine is a corrosive yellowish-green gas. Its atoms have 7 valence electrons. When mixed, the two atoms combine explosively as an electron moves from each sodium to each chlorine atom. A closer look at the resulting product reveals the formation of small white sodium chloride particles, also known.
So this white solid is our very well known thing, the table salt. It is prepared, it may be prepared, not always it is prepared that way. It may be prepared with sodium, one solid, and one chlorine gas, and greenish in color. So sometimes gas may have color like chlorine having greenish color, and your solid salt is produced from that also. It may be produced that way. So one important feature from this experiment we can see, I will write and also you write, and we'll come to that. A solid on heating usually changes into its liquid state. We have done it earlier. So go on writing. A solid on heating usually changes into its liquid state. We know that, and that is there. On heating, just simply we can understand, if we heat ice, it will melt down to liquid water. The next one we have seen, because if we want to put the reason from the molecular level, because heating provides one thing. What heating will provide? Heating provides sufficient energy to molecules to overcome the intermolecular force of attraction. Initially, we said there was a huge intermolecular attraction. That's why solid can keep its own shape, one definite shape. But if you provide heat, then the intermolecular attraction will be less, and that's why it will be liquid. So heating provides sufficient energy to molecules to overcome the intermolecular force, of attraction. Is it okay to all of you? Otherwise, ask me. I think these are the same simple things to understand from molecular point of view. Solids stay in one place and can be held. In the right side picture, it says solid can stay one place. It will not move and can be held. So you can keep it in any container anywhere else. So it is also possible. Write it. So this is possible for a solid. So this is the characteristics of solid. So we will find that one in case of solid. In case of solid, can be cut or shaped. That's we actually observed in case of sodium. And you can cut also iron also, but that time cutting is required, many more things and harder things. So solid can be cut or shaped. So that thing we observed, because sodium is a soft solid. So we can cut it also in an easier manner, but you can cut iron also. So these are the characteristics of solid. We have seen these are the characteristics of solid. So these some simple characteristics we have to remember for solids. And on cooling, we know that a liquid can turn into a solid also. So we can get solid from liquid back again on cooling. So this is also possible. And these are also there. So change of state we studied earlier, and it is possible also. Now about liquid, last time we talked about these small things, a substance that has a definite volume but no definite shape is called liquid. Now this time we will pass a little more about the characteristics of it. So characteristics of liquid, we will start from its definition. Their volume remains the same. Write it. So characteristics of liquids, their volume remains the same. We know that the definite volume is there, but definite shape is not there. Next point, liquid change their shape depending on the container they are in. We also studied this point in the definition itself. Now I would like to show you one video clips and to understand further characteristics of liquid. Try to observe it and to get the idea what are the characteristics of liquid. We can get it from here. Check this one.
A liquid assumes the shape of the vessel it fills.
Akashlina, what characteristics we observe now?
Liquid assumes the shape of the container.
And what is the name of the container in which now the liquid is pouring?
Test tube.
No, test tube. Vedanti, do you have an idea? Name of the instrument?
No. I've seen it.
You have seen it. So it's not the test tube. And okay, I would like to also, Vedanti, can you say the name of this one? Try to show you. The middle one, can you name that one? Vedanti, can you name that one?
Which the man is holding, that one.
Yes, no, holding, yes, that one. In the left hand. We threw it. Yes. What is the name? At the center it is there on the table.
In that type of container, they do filtration.
But what's the name? Akashlina, what's the name of the container which is at the center? Yes? Yes, it's conical flask. It's conical flask. So this you have to remember. And the left side, extreme left side, in case of extreme left side, check this one. In case of extreme left to our left side, that is beaker. In extreme left side, that is our beaker. Check this one. So it is also there in our beaker. Is it? So this is our beaker, and then so check this.
A liquid assumes the shape of the vessel it fills.
This equipment is known as graduated measuring cylinder. Graduated measuring cylinder. Why graduated? Because in between 0 to say 20, 30, 100, you can measure anything. So marks are given. So graduated. And as you can measure from here the volume of the liquid, and that's why it is known as measuring cylinder. And graduated measuring cylinder.
At the top, it is enclosed by a horizontal boundary known as the free surface. Liquids are difficult to compress.
Akash, Lina, can you say what characteristics we are observing now?
Liquid can be pressed.
Liquid can be?
Pressed.
Vedanti,
Hmm.
listen once more.
Liquids are difficult to compress.
Vedanti,
Liquid is stopping because of the pressing. It is
Akash,
not
Lina,
coming out.
what is the characteristics of the liquid here? Akash, Lina.
Liquids are difficult to compress.
Yes, liquid is hard to compress. So compressibility is here. We are observing the compressibility. Liquid is hard to compress. So compressibility is very low. Compressibility is very low. So we can say that also. Now we are coming back to here. So liquids can flow or be poured easily. We have checked this point. They are not easy to hold, so it will fall down from one container. If they can get path, so they will flow away from that container to other place. So liquid having a property to flow, that is possible. Liquids can flow. And also we checked other properties. Like first property also checked, change their shape according to the container. Then heating a liquid can turn it into a gas. We know that. And the last, compressibility of a liquid is low. We checked this property, these characteristics also. So it is very hard to compress liquid. In a syringe, we took that liquid and tried to compress, but we failed. So compressibility of a liquid is low. Is it okay? Vedanti, do you like to ask question?
Yes. It is not clear to me about the compressibility. It is not.
Compressibility means if you press it, you cannot change its volume. By pressing, you cannot change its volume and shape. Rather, you can say its shape you cannot change by pressing. Go on.
And another also I have, that is the first characteristic. Their volume remains the same. That is also not
So
clear.
volume remains the definite, because if we take 100 milliliter of oil in a conical flask, and if you pour it in a test tube, then it will remain 100 milliliter. So the volume remains same, and that's why we say in case of the definition, the definite volume of the liquid is there. Is it not? So definite volume is the characteristics of liquid, but definite shape is not. Is it?
Yes.
Okay, so that's why. So first point, their volume remains the same all the time, because it is this property, we can see it. Now next one, see these two pictures. Akash, Lina, can you say what characteristics we can get it from these two pictures?
Some liquids are poured into the container.
Then what characteristics we can get from the liquid?
The volume of this liquid are not changed.
Once more.
The volume of these liquids are not changed.
But how can you say so here? How can you say that thing? We have not taken this volume to another container. Otherwise, you cannot say like that. Is it not? Vedanti, what characteristics we can draw from this experiment?
Um, it is poured in different types of vessels.
Yes, that's true. But what characteristics we can say from this experiment, these vessels? Okay,
The
I have written it. Check this one. Can you understand that? Vedanti first.
liquid seeks its own level.
Then what does it mean?
Liquid is in its own level.
What did it mean actually? Akash Lina, what do you understand by this line?
Are in same level.
Okay, from this experiment, you see that if we pour liquid in this container, this place, and as all are connected, then what will happen? Liquid will flow here, and that will rise. Whatever may be the shape of the container, if they are connected, all the time liquid will flow and rise up to that level. That's why the level of all this will be same. If they are connected, this every time liquid will rise up to this level. So liquid seeks its own level if they are connected. That is same for the right side also. Whatever may be the shape of the vessel, if all are connected, it will rise to this up to this level. That's why our water tanks are kept on the top of the roof. Water will go down through the pipe and it will rise up even up to that level where the roof is. They will try to do that. That's why our water tanks are kept at the roof. We follow this point. So liquid seeks its own level. Write it down, and if possible, at least draw one picture. It will remind you what is actually meaning. Draw any one picture as you like. If you have pencil, then fill the inside with the pencil. Said. So next point, cooling a liquid can turn into a solid. We discussed and we know that thing. Cooling a liquid, if we cool water, we get ice. So cooling a liquid can turn into a solid. Into a solid of its state, means that substance will remain same, but it will be in the state of solid. Now, gas, last time we discussed and also talked about the color. Sometimes we can see the color. Akashlina, can you name the gas here present?
Iodine.
Yes, it is iodine. And today we checked one gas with greenish color. What's the name?
That was chlorine.
Chlorine. It is iodine, and that was chlorine. Chlorine. Okay. So sometimes we can see the color of the gas, but sometimes we do not see, because as we are in the air, we cannot see the air color. So gas is that which has neither a definite volume nor a definite shape. We talked about that. Now again, the characteristics of gases. First one, from its own definition, gases spread out and change their shape and volume to fill up whatever container they are in. Is it? So in whatever container you will take, suppose if you are taking the gas in a conical flask, it will take the shape and the volume of it. If you put it down in another big box, in a cubical box, then it will take the whole volume of the cubical box and the shape will be cubical. Write it down. So it will spread out and change its space, shape and volume. So there is neither definite shape nor definite volume. They will certainly have shape and volume, but not definite. It doesn't mean that they do not have any shape or volume. They will have, but that will be of the container, not any definite shape, not any definite volume. Yes. Okay. So gases can be compressed. Gases can be compressed. I will try to show one thing. Let me check once more. Try to see this one and to understand. Let me show you. First to check this one and then to come. Try to see this one and to understand that also. So did you get the point? You cannot compress more. So if bubbles are here, and then if you try to press it, so bubbles you can sometimes some amount of gas you can compress, but so there is a gas bubbles were initially there, so you can compress it and compress it in a very small place. So bubbles will be compressed. So gas can be compressed. So this is possible in case of gas. Now heating a liquid can turn it into a gas. As we know, when we heat water, we get water vapor. So heating and cooling, both the side you have to know what will happen if you heat it and if you cool it. So heating a liquid can turn it into a gas. So change of state is there, and we talked about earlier also, and we know in our day-to-day experience also. Cooling a gas can turn it into a liquid. Very simple one. So cooling a gas, turn it into a liquid. Write it. So we will jot down in a single place about the characteristics of solid, the liquid and gaseous. And gases are often invisible. Generally, we cannot see it. There is a color only you can see it. So gases are often invisible. Sometimes they are visible if they have color. And that time they may ask you a question. Can you name 2 gases where we find color? And we have seen that. Now one thing, check this one and Vedanti answer it. What animation is showing us? What is the thing we can observe it from here?
Something is heated, and once the temperature is going on and down.
Yes, then what is the relation between that?
Cannot understand what is going on.
Okay, Akash Lena, can you understand what is going on?
The water is heating and the volume of gas is increasing.
Volume of gas is increased when?
When it is heating, the volume of temperature is also increasing. And the volume of gas is also increasing.
Okay, so check this one first. You say first one we are going to understand. So heating is going on means temperature is increased. If heating is going on, temperature is, that's fine. First we have seen that. And yellow gas, this is your gas. Yellow gas is here. And if temperature is increased, then right side there is a marking point, the volume. 1, 2, 3, 4, 5, 6. If temperature is increased, we are observing that volume is increased. If the gas remains, the total amount of gas remains same, but only if you increase the temperature, the volume of the gas will be increased. Check this one. If you increase the temperature, the volume of the gas will be increased. If you reduce it, again, the temperature, if you reduce the temperature, the volume will be reduced. Vedanti, what is volume?
Volume is something that changes of gas but does not changes.
No, we didn't say like that. We talked about definite volume every time. Then what volume is? What is volume?
Volume is something.
Not something. When we talked about the definition of matter, that time it was there also. What's that? What is the definition of matter?
Matter is something that occupies space and has a fixed volume.
Space and occupies space and volume, the same thing. The space occupied by an object, that is the volume. And what is the definition of mass? Then it is not fully clear. Vedanti, recollect once again. Definition of mass. That definition of matter, not mass, matter.
A substance that has mass and occupies space.
Yes. So occupy space, that space is volume. So here volume is this, the gas occupying space, that is volume. So volume is less when temperature is less. If you increase temperature, then volume will be increased. So there is a relation between the temperature and the volume of the gas. Is it clear? Akash Lina, is it clear? Can you tell me once again? First tell me what is volume. What is volume?
The space taken by an object.
What is volume?
The space taken by an object.
A space occupied by the object is known as volume. Okay, and then what is the animation is showing here?
When the temperature is increasing, the volume is also increasing.
Yes, yes. If temperature is reduced, then volume will be also reduced. So that will be for gases. So volume of gas increases with the increase of temperature. Write it down in the characteristics. So this characteristics of gas is here. Volume of gas increases with the increase of temperature. And that's why we find when you are heating the milk, it may rise and fall down from the container if you are not careful, because the gas present within the milk will be expanding, and that's why there will be a spilling of the milk from the container. Have you seen, Vedanti, that type of thing? The milk is coming out of the container because you are warming it and not careful.
Yes.
Yes, because the gas is present there. Okay, so volume of gas increases with the increase of temperature. Here it is one thing more. Another animation. Akash Lina, to understand first. What is here? No, once more.
When the temperature, when the gas is raised, the gas is coming down.
When?
When the gas is pressed.
Gas is pressed. That means what is coming down? What is the coming down? What is this one? What we said, talked about? What is that?
Volume.
Volume, yes, this is volume. Vedanti, what is the meaning of this experiment?
If the volume is increasing because of the pressure given.
No, volume is not increased when pressure is given more. See that one. Now I am not satisfied with the answer. Okay, I will show you this point. At 1, check the volume is 4. Is it okay, Vedanti?
Yes.
Okay, now I will increase the pressure, check this meter, and then check this volume. Now it is 1.6 and the volume is below 3. Then what do you say now?
If pressure is increasing, then the volume is going down, decreasing.
Yes, so volume, if you increase the pressure, volume will be decreased. So it is reverse. If you increase pressure, then volume will be decreased. Not like temperature. Is it okay?
Yes.
Akashlina, is it okay? So it is not like temperature. When temperature is increased, volume will be increased. But if you increase the pressure, volume will be decreased. Write it down. Volume of gas decreases with the increase of pressure. Is it okay? Otherwise, I will again explain you. So that's all for today. We have talked about matter. You recollect all these things and remember, and also try to give your explanation. Not only memorize something, and we have talked about reasons also. Why do you observe all these type of things? We have seen examples, experiments, what we can see, how we can see, and how can we state the characteristics of either a solid or liquid or gas. So that, thank you for joining this class, and next time we will meet on 1st of September.